Hello, I'm Shantai. I'm very glad to share our ICCV work, TubeLink, a flexible cost-tube framework for universal video segmentation. The goal of this paper is to solve the three different video segmentation into one framework, named universal video segmentation. However, most of the approach for different segmentation tasks have the specific architecture. We first summarize the different methods for the different tasks. As you can see, for VS, VAS, and VPS, they have different ways of inference and usage of the multi-frame. Also, they have different ways of matching and association. So you can see that recently several work perform the universal architecture for the different tasks. However, this work have a shortcoming or issues of performance. So we raise three different questions. The first is we found that recently a challenging VPS dataset introduced. This bring more challenging. Another problem is the performance issue of universal segmentation. For example, both video kinet and tube former cannot achieve better result on VS dataset. Moreover, since the video have a different lengths, and so we should design a more flexible architecture to support both online and near online. In this way, our algorithm can support a more diverse video input. So in this work, we introduce a near online approach named TubeLink. The key insight is to explore the cost tube association rather than the cost frame. So also, due to the flexible design, our method can support three different video segmentation tasks. Here is a short introduction for our task. We first divide the video clip into subclip, and we obtain the subclip by a transformer architecture. Meanwhile, we can obtain the global query and its corresponding tube mask. Then we perform a tube association on the global query and tube mask. We achieve state-of-the-art result on three tasks of the different dataset. We first perform the exploration experiment on table-wise matching. As you can see on the table 1, we simply replace the table matching for two different methods. Without the retraining, we found that the performance can improve the consistently for different dataset and different tasks. This is because the tube-wise matching contains more stable and consistent temporal information, so the segmentation can be more smooth. So this finding motivated us to explore cost-tube relation. So we first adopt the multi-former VS as a strong baseline by adding the stub query. This architecture can support video semantic segmentation and video panoramic segmentation. Then our goal is to learn a cost-tube relation. The cost-tube relation contains two items. The first is cost-tube linking. We directly learn the global query relation by the self-attention, and then we perform the cost-tube temporal constructive learning. This is the contribution, our main contribution of the work. We learn the constructive query association according to the tube mask. That means that we perform the same instance same instance of the different frame together, and we push away the different instance in different frame. So our architecture training is that we perform tube-wise training segmentation loss for each tube, and cross-tube training for the tracking loss. So we also show the ablation experiment. We found that at temporal constructive loss and cost-tube linking can improve the performance considerably. So the global query works better on the sparse query, and also we found the tube mask as association performs well. We achieve state-of-the-art result on the different task and different dataset. Here is some visual example. As you can see that our method can achieve better results. So thanks for your watching. Our code is available on the GitHub.